Defect analysis can be extremely valuable in predicting final part performance, especially in additive manufacturing. Differentiating between build cracks and pores is critical for characterizing this microstructure, especially because under load conditions, cracks and pores behave very differently. When performing defect analysis in EM data, variation in feature contrast and background noise can pose challenges for an accurate automated solution. In this case, cracks and pores have very similar contrast and are often connected. Separating them can be challenging. In the past, identifying crack and pore size will be achieved by manually annotating the defects and measuring the point-to-point size. As we apply the recipe, we see that MIPAR is able to quickly and accurately detect the defects and output the count, size, and area fraction. These measurements are critical for correlating manufacturing process to final build performance. With the cracks and pores identified and measured, it's relatively straightforward to produce a summary report of the measurements. It is just as easy to generate a more detailed breakdown of the data and output a distribution report. Accurate detection, measurement, and report generation is available when an operator is measuring a single image or a batch of 1,000.